Friends, greetings of the day. The channel Hospitality Education PPT welcome you all once again to our session, that is lesson 3 on facility planning. And under this, we are going to discuss about the project management. Already we have completed 2 sessions on this, and today is our third session, which is another one very important aspect of the project management with the critical network analysis. So, without wasting further time, let us proceed to the next slide. As usual, let us find out the scope of study for this particular session. Firstly, we are going to discuss about the calculation of slack to find out the critical activity, and then to identify the critical activity, we'll discuss about a foolproof method. Next, we'll try to calculate the relax to find out the critical path. We'll also enhance the idea what is path and critical path, and we'll try to know more about float or relax. Okay, so this is overall study we're going to do today in this particular session. So why to wait? Let us begin with the first one, how to calculate the slack to find out the critical activity. Now, here you can see that we are going to calculate the slack, which is denoted with S in a given network, to find out the critical activity. That is our objective in this particular slide. Before we go into the detail of this network and find out the critical activity, let us just try to recap about the critical activity and about the concept of slack to connect our previous lesson. So what is critical path method or critical path analysis? We have discussed in our last session that the critical path in any network is the longest path through the entire network. So if we just calculate the duration of each activity in the critical path, it will be, if we add on that, whatever days will be coming out, that is the longest time to be taken to complete that project, and that is the critical path. So once again, what we are saying, the critical path in any network is the longest path through the entire network. That is the first one. Second one, we have also discussed that since all the activities must be completed to complete the entire project, the length of the critical path is also the shortest time allowable for the completion of the project. So longest path automatically becomes the shortest path to complete the entire project. Okay, that you are going to keep in your mind. Third one, thus, if the project has to be completed in shortest time, all the activities on the critical path must be started as soon as possible. That means at that point on the critical path, no delay is possible. Okay. These activities are called the critical activities. Fine, that we have discussed already. If the project has to be completed ahead of the scheduled time, then the time required for at least one of the critical activity must be reduced. That is very obvious. If your project is saying, the network is saying that 14 days is the longest time, and that is also equivalent to the shortest time to complete the project without having delay on the critical path. Now you want to reduce it further by 1 day at least. You need to at least reduce 1 day in any of the critical activities to reduce the total project time. So we are saying if the project has to be completed ahead of the scheduled time, in this case, for example, we have mentioned, say, scheduled time is 14 days. Then the time required for at least one of the critical activity must be reduced. Suppose instead of 14 days, you want to complete it in 13 days. You want to reduce it further. Then what is to be done from your side? The time duration on each activity of critical path, one of the activities out of the critical paths has to be reduced by 1 day, then only it will be possible to reduce, otherwise it is not possible. Okay. Further, any delay of the critical activities will increase the project time. Same thing. If you want to reduce, then reduce it on the critical path activity only. If you want to increase, suppose if you are not able to complete some task or some activity on the critical path, then automatically what will happen? Suppose instead of 5 days in particular activity, you have consumed 1 day more. So automatically that will become the longest path, and that will be the increase of the project duration. Try to keep that point in mind. Similarly, the activity does not lie on the critical path is called non-critical activity. Okay, where delay is possible. These non-critical activities may have some slack time. You can start little, you can start early, finish late, then relax. You can start early, then finish early, and then relax. You can start late and finish late, then relax. Like that, you can do. There will be some slack time. The slack is what? Slack is the amount of time by which the start of an activity may be delayed without affecting the overall completion time of the project. So there are two things we are getting. One is a critical activity, one is non-critical activity. By chance, if you take less time in critical activity, one of the critical activities, your total project duration time will be reduced. That is good for you. And if by chance you are not able to complete the critical activity in right time, then what will happen? The project duration will be increased. So project duration is totally depending on the activity of the critical activity. That's why it is known as the critical activity. But non-critical activities, some slack or delay is provided over there. So if you do some slack or delay over there, your project duration time is not going to be changed. Am I clear? So critical activity, that is the specialty of the critical activity. You have to find out which one is the critical activity where no delay is possible. But a critical activity has no slack time, as I have discussed right now. To reduce the overall project time, it would require extra resources at extra cost to reduce the time taken by the critical activity to complete. Now, as I'm going back to the same example, suppose the project duration is saying 14 days to complete the project. That means it is the longest path on the critical activity. Now, if you want to complete the project by 13 days, what you need to do? You have to reduce 1 day on any of the critical activities. Now, to reduce 1 day, to reduce by 1 day in any of the critical activities, what you need to add on over there? You have to add extra resources. What are the resources? It can be extra cost because of the material, and machine. You have to employ more manpower. You employ some machine you require. You employ some more resources over there, materials. Then only it is possible to reduce it by 1 day. And if you reduce it by 1 day, then your project duration will also be reduced by 1 day. So instead of 14 days, it will become 13 days. Okay. So now remember, we are going to discuss about the slack. So naturally, it is very important to keep it connected with the mind. Now, Determination of the slack or float. What we have discussed then? The float or slack of an event is the amount of time available by which it is possible to delay its completion time without extending the overall project completion time. That means slack or float is possible only on the critical path without extending the overall project completion time. The amount of time available by which it is possible to delay. That means you can delay the work for a particular day or days by which your project duration time is not going to be affected. So that is known as float or slack. Now we are getting another one concept of total float, which is denoted by X. Maximum relax or delay provided to any activity without affecting project duration. In an activity, it is the difference between latest start time and the earliest start time. That is the difference. Maximum relax or delay provided to any activity without affecting the project duration time. So project duration time will remain the same. Now to understand this in a better way, we have taken one example, we are taking another one example out here. That is, suppose your activity is A, is starting from ith node and finishing on jth node. Your earliest start time is 5 days and latest start time on ith node is 8 days. On 8th day you can start. And then according to this, what is the difference? The slack is the difference between the latest start time minus the earliest start time. So 8 minus 5 is equal to 3. That is your slack time. What you are saying? Maximum relax or delay provided to any activity without affecting the duration. In any activity, it is the difference between latest start time, Li is the latest start time at node I, and the earliest start time. Okay, that is E. E is here 5. Earliest start time and latest start time, that is the difference. Difference is known as total float. Clear? So always calculate the float, that is S, by L minus E. Latest start time minus earliest start time. Remember this formula. Now we are having some consideration on this. If the value is 0, the activity becomes critical activity. So S, if the value of S at any node is 0, that will become the critical activity. So similarly, if at any point of time here at ith node, if the value of S is 0, and on the jth node, if the value of S is 0, then this activity A becomes critical activity. Otherwise, if the value is more than 0, the activity becomes non-critical activity. Fine? That is the concept of slack. Depending on this concept, let us go and calculate the slack time. Now this is our network from where we have started. So at any node, the difference between L and E is the slack time, as we have discussed just now. So let us find out what is the slack time at node 1. Node 1, the slack time, the L is 0, E is 0, L is the latest start time, E is the earliest start time. Difference of these 0 minus 0 is equal to 0. So here at node 1, the value of S or slack is 0. Let us go to this. At node 3, here the difference between latest start time and earliest start time, that is L minus L, 5 minus 5 is equal to 0. So here also slack time is 0. Let us find out this. Here you can see the value of L is 6, value of E is 3 at the node 2. So automatically the slack is there, that is 3. Okay, fine. Let us find out on node 4. On node 4, the value of L, that means latest start time is 10, earliest start time is 10, and difference of that is 0. So at node 4, the slack is 0. Similarly, at node 5, the last node of this network, where value of L is 14 and value of E is 14, and 14 minus 14 is equal to 0. So S is also 0. So we have calculated how, and then depending on these, we have mentioned in our earlier slide that if the value of S is 0 at any node, then that activity becomes critical. So if that is the thing, then if the value of S is 0, the activity becomes critical activity. So we can see that in node 1, the value of S is 0, and node 3, the value of S is 0. So it is one critical activity, and critical activity is always given by the double arrow line like this to indicate that this is a critical activity. Clear? Then next, node number 3, the value of S is 0. Node number 4, value of S is 0. So that also becomes your critical activity, and it is given a second line of arrow to indicate that it is a critical path or critical activity. Similarly, if you see that node number 3, the value of S is 0, and node number 5, the value of S is 0. So this activity 3 to 5 also becomes your critical activity. And at node 4, the value of S is 0, node 5, value of S is 0. So this 4 to 5 is also becomes your critical activity. So what we can see out here is that we are having multiple critical activities out here. One is 1 to 3, 3 to 5, that is one path, critical activity, critical path. And another one is 1 to 3, 3 to 4, and 4 to 5, it becomes a critical path. So that means there are some point of confusion. We have to now think whether this formula we have adopted to calculate the slack, and depending on that to find out the critical path or critical activity, is that always correct? Is it always holding good? Because here we can see there are two critical paths available in front of you. Now which one is correct? We have to find out that. So naturally, if we want to calculate these, this slack calculation is not always hold good. This is not exactly a foolproof method. What we are saying out here, to identify the critical activity, the formula S equal to L minus E is not always hold true. We can see this is also a critical path. 1 to 3, 3 to 4, 4 to 5 is a critical path. Again, 1 to 3, 3 to 5 is also a critical path. Then which one is correct? So it is not holding good then. To overcome that, it is suggested to apply the formula, that is to calculate the slack L minus C minus duration, which will give a foolproof result in calculating the critical activity. So instead of applying the formula S equal to L minus E, we'll try to apply the formula S equal to L minus E minus the duration of that activity. Then only it will be absolutely a foolproof formula to calculate the critical part. And we'll do that right now. We'll go for a foolproof method. So according to foolproof method, what is the critical activity? we are saying again, the activity, earlier we have told there is no relax possible. Now we are saying the activity which do not have any relax or delay provided, that is exactly known as the critical activity. What is relax? Relax is equal to the time provided minus the duration. Time provided is what? Latest start time minus earliest start time minus the duration as we have discussed just now. So that is our relaxed calculation. Depending on that, let us take one example out here. The activity A starting on ith node, finishing on jth node. Duration is 3, dij is 3, your earliest start time is 3, latest finish time is 7. So what is that? Time provided, latest finish time minus earliest start time equal to 7 minus 3, that is a 4. Time provided, 7 minus 3 is 7 minus 3, time provided 4, actual duration is 3. So what is the relax? Time provided minus duration, that is what in this case 4 minus 3 equal to 1, that means 1 day relax is possible. So in that way A is not a critical part. Okay. So now the common consideration, if the value of relax is equal to 0, then that activity will be critical activity. You got my point? So not only S, if the value of relax is what? Relax is latest finish time minus earliest start time at any node minus the duration of that activity, that becomes your critical activity. If the relax is 0. If the value of relax is greater than 0, then that activity becomes non-critical activity. Very simple. So by applying the calculation of A's, we have seen that it was not a foolproof method. So one more foolproof method we have discussed, will calculate the relax, not the slack. Relax, how it is calculated? Latest finish time minus earliest start time minus the duration. So 7 minus 3 minus 3 is equal to 1. In this case, this activity A is not critical. If the value of relax becomes 0, then only it will become critical. Otherwise, if it is greater than 0, it is non-critical activity. Correct? Depending on that, we'll proceed to the next and calculate the relax in the same network. So we get the network now. Earlier on this network, we have calculated the slack. Depending on the slack, we have found out the critical activity. Now let us see that whether it is to calculate the relax, whether it is good or not, that we will find out. Good means it is correct or not, we will find out by applying a foolproof method by calculating the relax. Now relax of B, that means B is the activity. Relax, latest finish time minus earliest start time, that is 5 minus 0, that is the time provided, minus the duration. Duration is 5 minus duration, that means relax of B is 0. Done. You got it? Next is relax of G. Latest finish time is 14. Earliest start time is 5. So 14 minus 5 is the time period provided, that is minus the duration. Duration is 4. And so here the relax of G is 5. So it is not exactly 0. It is more than 0. Now relax of C. C is this activity. Here the latest finish time is 10 minus the earliest start time is 5. minus the duration, that is 5. So relax of C is 0. Now relax of E at this point. Latest finish time is 14. Earliest start time is 10. So 14 minus 10 is your 4 days is your time period provided. Duration provided 4, that is minus equal to 0. So relax of E is also 0. Then what happens? The RG, relapse of G becomes non-critical because it is more than 0. A value of relapse G is greater than 0, so it is non-critical. By calculating slack, it was guiding us that it is also critical. But by right now, by calculating relax, we can find out it further that activity G is no more a critical activity. Then what is a critical activity in this case? It is removed. So your critical activity remaining is B, C and E. The actual critical activity is B, C and E. That means 1 to 3, 3 to 4, 4 to 5 is your critical activity. Here 1 to 3 is the duration, that is 5, plus 3 to 4 duration is 5. So 5 plus 5 is 10, plus 4 to 5 the duration is 4, that means 14 days, the actual finishing time. Though it was also longest path, but out of that G has got a relax of 5 days, so G is no more a critical path. So by calculating slack at any node is not always the foolproof method. So you have to apply the relax method to exactly find out which one is your critical activity. Clear? Very good. Now, whatever we have learned to calculate the slack, to calculate the relax, depending on that, the backward path, forward path method, and then finally calculating the critical path, whatever we have learned, that is a very detailed method. We're not going to follow that. We'll show you now how to calculate the critical path on the basis of path calculation. That will be much more easier. So at any point of time, any network is given to you. By only calculating the path, you can find out which one is your critical path. We did not go for a forward method, backward method, and then followed by the calculation of flow, slack, then calculation of relax. You got my point? Let us try to do that now. This is the way you are going to do in your examination. So path exactly means what? The way from first node or event to last node or event. That is known as the path. Critical path. One activity, two activity, and three activities. Suppose these are all critical activities. Once you take on that, starting from the first node to the last node, it becomes a critical path or a path. Simply a path. Let us take this network once again. It is a known network, already you have used many a times in these discussions. Now here, let us find out the path first. All the probable paths. Probable path means starting from the first node to the last node, how we can reach starting from the first node to last node. That is our probable path. What we can see that we can go to 1 to 2, 2 to 5 we can reach. We can also go 1 to 2, 2 to 4, 4 to 5 we can reach. That is another one path. We can also follow 1 to 3, 3 to 4, 4 to 5, that is another path. And also you can follow 1 to 3, 3 to 5, that is another path. So these are all probable paths. We can see that path 1, as I have mentioned, 1 to 2, 2 to 5. So it is written 1 to 5. 1 to 2, 2 to 5. Path 2, 1 to 2, 2 to 4, 2 to 4, and 4 to 5, that we can find out from the network. Path 3, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 2 to 3 is a dummy activity. Okay, so that is another path. Path 4, 1 to 2, 2 to 3, 3 to 5, that is another path. And path 5, 1 to 3, 3 to 4, 4 to 5, another path. And path 6, 1 to 3, 3 to 5, another path. So all these paths are probable paths through which we can start from node 1 and reach to node 5, that is the end node. So this is a probable path. It will be very easy to find out from the network. So your duty will be to first to draw the network, and from the network find out the probable paths. Once you know the probable paths, then you calculate the length of the path. In the first case, 1 to 2, 2 to 5, 1 to 2 duration is 3, and 2 to 5 duration is 4. So 3 plus 4 equal to 7 days. Similarly, we can calculate all these durations. Okay, 7 days, 11 days, 12 days, 7 days, 14 days, 9 days, all these probable paths, and correspondingly their length of path we have calculated. That is possible, very simple arithmetic. Okay, now observations. What is that? Out of these length of path, what is the critical activity? The longest path in the network is the critical activity, critical path. So this is the 14. That means 1 to 3, 3 to 4, 4 to 5 is the longest path. And this is known as longest path in the network. Fine. Now, so path 1, 3, 4, 5 is the longest path in the network. Now, another conclusion. What is a critical path? The path which consists of only critical activities. So, this is the critical activity path because this has become your longest path. So, critical path here in this network is 1, 3, 4, 5 or BCE according to the network. That is your why, because the longest path, the time duration is the shortest time for the project, that is 14 days. So it becomes your critical path. So longest path is become your critical path. So critical path noted by CP is equal to the longest path in the network. We can see that by simple calculation of path. Also, minimum completion time of the project or minimum project duration is denoted as PD, which is the value of P on the last node. Value of P on the last node is equal to the length of the critical path. So length of the critical path is 14. If you remember the project network, the last node was 14. That is the minimum possible duration of the project. The project duration, minimum shortest days, and the critical path and the longest path at the same time. So minimum completion time of the project or minimum project duration equal to the value of the E on the last node. That is the length of the critical path. And we can see that is the 14 days. So we have calculated from one simple network that how to calculate the slack depending on the relax, find out the critical path and the project duration time. Here we have followed another one method, that is the path method, where in a network we have found out the probable paths and then calculate the length of the path, whatever probable paths we have received. The longest path out of all those probable paths is your critical path, and that is the time of your project duration. Fine, very simple. Now we'll try to understand little more about the float or relax. To understand that, let us go back to float and relax once again. Float means the always calculated by S equal to L minus C. Latest finish time by the, latest start time minus earliest start time. The difference between that is known as the slack, and initially we have told that if the value of S is 0, that becomes critical, but later on we have observed that that is not always hold good, so we have to go for calculation of relax. Okay, now let us talk about the float or relax little more. There are different types of float. Number one is total float, which is denoted by TF. Okay, what is that total float? The maximum relax or delay provided to any activity without affecting project duration. The maximum relax or delay provided to any activity without affecting the project duration, that is known as the total float. We'll take one example very shortly and try to make you understand it very clearly now. Number two is a free float, which is denoted by FF. What is a free float? Free float is relax or delay provided to any activity without affecting earlier start time of the successor. Relax or delay provided to any activity without affecting the earlier start time of the successor. That is your total free float. Okay, and then third one is independent float, which is simply denoted by IF. And what is that simply independent float? Relax or delay provided without affecting the earliest start time of the successor as well as the latest finish time of the predecessor. We have to calculate that. Let us see one example. Here you can see there are three activities. A is one, which is starting from the ith node, finishing at the jth node, and duration dij is 5. Now here some more information is provided that node I, the earliest start time is 2, and node J, the earliest finish time is 50. Okay, and then node I, the latest start time is 6, and node J, latest finish time is 20. All these informations are given to you. Depending on these informations, we'll try to find out these three different floats. First one is the total float. Total float of activity A, it is denoted by this. Total float of activity A. What is that? Latest finish time. Latest finish time is LJ minus earliest start time is EI minus the duration. So here in this respect, 20 minus 2 minus 5 is your 13 days is the total float. Okay. Similarly, free float of A. If you want to calculate the free float is saying that relax or delay provided to any activity without affecting the earliest start time of the successor. Who is your successor in case of A? Successor is C, and the predecessor of A is B. Okay, so C is your successor at this point. So what is the free float is talking about? Without affecting the earliest start time of the successor. The earliest start time of the successor is what? E15, because earliest finish time is 15 of activity A. That means that is the earliest start time of activity C. So 15 minus 2 minus 5, it becomes 8 days is your free float at A. That is written like this. Now we'll talk about independent float. What is that? Independent float of A is talking about without affecting the earliest start time of the successor. Earliest start time is EJ, as well as the latest finish time of the predecessor. Latest finish time is LI. Okay, minus the duration is the float. What is that? So 15 minus 6 minus 5 duration is equal to 4 days. So you can see we have calculated, depending on this definition, total float, free float and independent float. Now let us try to see the relationship between these three. We can see that total float was 13 days, free float was 8 days, and independent float is 4 days. So it is diminishing. So you can see the total float is greater than free float and free float is greater than independent float. That's the relationship we can see virtually out here. And for any critical activity, the value of floats must be 0. That means at that point, total float, free float and independent float is equal to 0. That is a calculation of relax. Okay. Now how to remember this formula? You may find it a little difficult. Now I will show you some pictorial view that how to remember this. Let us see this example first. One activity A starting at ith node, finishing at jth node. Ith node is known as the tail event. Jth node, the finishing node, is known as the head event. Okay. Duration is Dij to complete. Ei indicates the earliest start time. Li indicates the latest start time. Ej indicates the earliest finish time, and Lj indicates latest finish time. So you got all these information in front of you. Now try to visualize this float formula. Let us plot this. This is your earliest start time. This is your latest start time. This is your earliest finish time. And this is your latest finish time. Now here, total float is what? Latest finish time minus earliest start time minus Dij duration is your total float of that activity. Similarly, let us find out free float. Free float is earliest finish time minus earliest start time minus duration is your free float. Clear? To remember that, you can visualize the formula now. Don't have to remember, mug up. And then independent float, earliest finish time minus latest start time minus the duration. That is your independent float. And we have told you that in case of critical activity, all these three will be 0. Then what is this 2 empty area? Here, tail slack. Slack, it is known as the tail slack. Tail slack is SI, LJ, latest finish time by the latest latest start time by earliest start time. That is your tail slack. Latest start time by earliest start time. And similarly, the head slack is what? Latest finish time minus earliest finish time. So if you remember this, you'll get a total formula installed in your mind. Okay. So what exactly we have learned today? We have learned how to calculate the slack, whether the slack is a foolproof or not, that also we have discussed. If not, then how to make it a foolproof. Then we are depending on that, we have calculated the relax. And to calculate, after calculation of the relax, we found out that which one is exactly the critical path. Then we have discussed about, instead of calculating the slack and relax, by calculating only the probable paths, we can find out which one is the critical path. That also we have discussed. We have also discussed about the float and relax, the formula, three floats, different floats, and how to remember their formula. We have discussed all these things. And now we know how to identify a critical path without calculating the slack and relax. Only your network to be drawn will calculate the paths, and out of that the longest path is your critical path. Very simple way of doing it. So thank you very much for attending this session with all your attention. Hopefully we have enjoyed the session. If not, please put me in the comment box. If you have liked the session, please press the like button, subscribe the channel if you have not yet done, then press the bell button also, so that you can get the next alarm as earliest. And and then don't forget to give your valuable comments and feedback in the comment box, which will be a kind of inspiration for me. And also, more importantly, if you are having any doubt in any of the areas, you can connect me there. Definitely I'll get back to you with the proper clarification and analysis for that. So till then, thank you very much. Next time again we'll meet with another one exciting lesson like this. Take care. Bye.